civil geometry, and design intent. All right, let's talk a little bit about just normal geometry. If you can recall back in the V8i days, back in MicroStation V8i or GeoPack V8i, whenever you began to draw information, if you drew some lines or you copied parallel, there was never a relationship between those elements. So if you drew a baseline, then you did copy parallel and you created a pavement edge, there was no relationship between the baseline and that pavement edge. So if you modified the baseline, the pavement edge did not respond. So there was a need to do a lot of rework. So this was really not the best way to go about things. Now I want to talk to you about civil geometry tools. These are rule-based set of geometry tools, and they'll create rules and relationships between geometric elements as they're created and edited. For example, if you draw an alignment and do an offset, you're going to build the relationship between the alignment and the line that you just copied. And what will happen is if you change the alignment, you will modify the line that was copied from the alignment. And this is because civil geometry tools remember and honor the relationships between geometric elements, changes to the baseline, and it will automatically update all dependent geometry. We call this honoring the design intent. Because of this, there's no waste and no reason to recreate and redo much of your line work. So let's just remember this. Civil geometry remembers and honors relationships. Rework is minimized when the project undergoes inevitable re-engineering. You know this always happens. I was always told never draw more in the morning than you can erase in the afternoon. And what we're going to cover in the lessons going forward is how to utilize this civil geometry. Civil geometry versus plain graphics. Okay, so what we're going to do now is we're going to look at the difference between civil geometry features and just plain CAD elements. We'll just call it smart graphics, dumb graphics. Maybe you don't like smart or dumb. Maybe we'll just say happy, unhappy. But right now what I want to do is let you know that anything that has color to it is a civil geometry feature. So anything above the center line is civil geometry. And anything below the center line here is, and in the color white, is just going to be plain unhappy MicroStation elements. There's no civil geometry to the white elements, okay? So let's take a look and see what the difference is. First thing I'm going to do is I'm going to click on one of my elements. And when I do, the first thing I'll notice is I get these dots here and some text. That's called manipulator. And I want to spend a minute to talk about the manipulator. It's super important. It's just really important to be able to see this text, to know how to control it, how to manipulate it. These dots, you can make them look any way you want. You can make them bigger or smaller. I really might like mine to be obvious. And the way you make this change, let's come up here to our search bar and let's type in PREF. There's our preferences. I'm going to come here to the view options, civil down at the bottom, and there's different little window panes here. And the one that I'm interested in, the only one that I care about, is manipulator settings. I'm going to show you here the manipulator settings. I've got mine set at 20. I'm going to change it to 10 so you can see the difference. This manipulates the size of the dots. The next thing I'm going to do is change the manipulator font scale. Now, the font scale is really, really important. It's how big the text looks like here. So I'm going to change that to a 1. Now, don't make this font crazy. Don't go looking for old English or just some crazy font. Make it a font that's super easy to read because that's what you need. You need clarity. Now these colors, you can also change selected color and the normal color. I definitely like those to be contrast. I don't like to pick one color and a different shade of that same color. I want them to be totally opposite, so it's super obvious when they're picked. Now I'm going to click on OK. And what you'll notice is that the text got smaller and my little manipulator dots got really small. And yeah, I don't like that. I want to make that a little bit bigger. But of course, you know what? If you got the eagle eye, leave it like it is. But me, I don't. I'm going to go ahead and hit preferences. I'm going to come back to my view option symbol, manipulator size. I'm going to go back to 20. I'm going to look at my manipulator font scale. I'm going to go for 1.75. Yep, I want to see it. Then I'm going to hit OK, and now it's much easier to see. Now let's just look at one of the advantages of the civil geometry features. You know, change is inevitable. There's always something that's going to change. You draw something and then something comes up later and you got to make the change. And one of the things that you want to think about is how little effort does it take to make the change? If you're using civil geometry features, you're going to reduce the need for a lot of the changes you'll normally make. If you're just using regular microstation elements, you know, CAD only, I like to call them the unhappy elements. I like to call the civil geometry features the happy elements. They're happy because they don't have to work as hard. The unhappy elements, man, they got to work super hard. So let's take a quick look at the difference of these two types of elements. I'm going to click on what's, you know, an alignment. I'm going to click on it. You can see the bearing and the distance of that element. Now, the manipulator text is super important because, you know, you could come in here, click on it, and change the length, all right? But for now, what I want to do is just make sure that I click and I can see here the direction. I can stretch it out or I can change the angle. And what I'm going to do is change the angle. And when I change that angle, what you're going to notice is that the red line moved. And the reason it moved with it is it was built with a perpendicular snap. So no matter what I do with my alignment, that line is going to follow suit and stay perpendicular. So that's part of, you know, the advantage when you've got your civil geometry features and your plain old elements, right? So you definitely don't want to use plain elements. And because you want to remember these relationships, I know some people don't like the word relationship, but look, in CAD, it's super important, right? So let's look at this and we can see again, let's change this angle and that perpendicular snap is relationship is going to be honored. And no matter where I move this, that relationship remains. That's pretty cool. Now, let's go back here and look at just a regular, you know, just a regular microstation line. And let's look to see what happens when we manipulate the center line here. Well, as you can see, there's no manipulator text. There's no way for me to come up here. Like here in the manipulator text, if I wanted, now here you can see the selected color is pink. Remember that in the preferences? Good. Well, if I highlight this number, you can see it changed to my selected color. And I could type 525 in here and it'll change that length to 525. Now, that's why civil geometry features are the best. Let's look at this regular unhappy line. We'll click on it. There's no manipulator text. There's no manipulator dots, but I can come here and let's do the same thing we did. And look, nope, not good. Now I would have to come back here and redraw this line. I would have to go back to my drawing. I'd have to, you know, find the right level, place a smart line, click, hit the perpendicular snap, and then redo that line. And that's just a bunch of work. Why do all of that when you don't have to? Just use civil geometry features, right? That is the best way to go. You just don't want to mess with old microstation lines. That's so 20 years ago. We're going to move on to something more advanced. Now, let's go ahead and take a look at our road here, right? So I've got my center line. I've got some intersecting roads on both sides. Okay, intersecting roads, driveways, just use your imagination, whatever you'd like it to be. And let's go ahead and the first thing I want to do is show you that I can click on this center line You can see my angle here, how it's laid out. You can see the length of that line. And you can see that there is a perpendicular snap there. Maybe it's a little tough for you to see, but that was created with a perpendicular snap. And what I can do is I can take this road and just move it anywhere. And anywhere that I move it, it's going to go. I can stretch it out a little bit more. And everything looks great. It's just super the way it works. It keeps all the relationships with all the fillets. Those things are never, easy to do. And if you had drawn them with just plain microstation elements, you would be reworking everything. If I came over here and clicked on my baseline, and again, I'm looking at my manipulator text here, I can see that I've got a manipulator button here, here, and here. I can see the distance from the pavement, the radius. This is the radius of that arc. It's just super easy to make changes. I can see the length of that line. I can see the radius of that curve, and I can see the length of this line and the bearing of it. But let's go ahead and just click on that element, and let me change that angle, right? When I change that, what you're going to notice is that everything that was done with civil geometry features modified. They changed, right? I'm going to go ahead and change this. I'm going to move it down a little bit. And of course, they all respond accordingly. But look who didn't respond. The microstation elements. None of those elements built a relationship with the centerline. See, you need friends. You should have made friends. If you'd have made friends, everything would have been easier. The relationships are great. You want to make sure that you continue to build the relationships with these civil geometry features, and it will save you a lot of time and trouble. I guarantee you, once you start using these geometry features, you'll never go back to the plain microstation lines. I mean, look, if I try to click on this element and I change the angle, the offsetting edge of pavements didn't come with it. There's no way to move it. This line here has no relationship with the center line, so it's never going to respond or react, but my smart features always respond and react. And that is why it's super important to always use the civil geometry features. One of the other advantages of using the civil geometry features is not just that you can manipulate the alignment and move the alignment and have the features move with the alignment, but you can also manipulate, let's call this the edge of pavement that we offset from the alignment. And when you look here, you can see the manipulator text, and we've got 3 different manipulator texts showing up. We've got one at the end, middle, and on the other end. Now, if I change the distance shown here of minus 60, and let's make it minus 80, it's going to treat that offset as a whole, right? So it's going to offset it an additional 20 feet. And if I go ahead and select the element, but this time I go to the end, one of the ends, and I say, let's make that minus 70. It's only going to manipulate that end. So you're still going to see the 70 over here and the 60 here. So those are different ways that you can manipulate the civil geometry. And it's something that you really need to consider as opposed to drawing plain old microstation lines and then having to do so many modifications. Make sure you use this civil geometry. Rules and relationships with civil geometry features, and how Open Roads understands geometry. So the next thing we're going to do is we're going to dissect the relationship portion of this lesson. As you know, we've already covered the difference between the civil geometry features and just regular graphics. But now we're really going to jump into the rules and relationships, and then we're going to talk about how Open Roads understands what's going on with the geometry. So that's what we're going to do next. And I'm going to go ahead and move over here to the right side, and I've got an arc, and I've got an offset line, and I'm going to go ahead and let's click on the arc real quick. You can see the radius is 2,000. You can look at the length of that curve and see the bearings on those elements. And now what we're going to do is we're going to click on this offset, and we can see it's a taper. It's not just a regular offset, but this is a taper. And you can look at the ratio of the taper here. It's a 1:4. You can look here in the beginning of this offset element. It's a 100 feet off of the element here, and it's at station 2 plus 0, and then we're going up here to 7 plus 0, 0. So as you know, if you're good with math, you can tell that's 500 feet. And this is minus 225 above that line. And you can see the ratio right there. Now, those are the rules, right? That's basically the relationships that are built here. You can do all kinds of different manipulations. You can change your ratio. You could change, the offset here. You could change the offset over here. You can make all kinds of manipulations based on the relationships. But what's really, I guess really what the big question here is, what's really controlling this piece of geometry? What's the design intent? And that's something that we want to cover next. We want to talk about that because we want to figure out, what's the primary design intent? Is it the offset values or is it the taper ratio? And that's something we're going to figure out. Now, it's not easy to do just looking at the heads-up display. You're not going to get the real info that you need. However, if you jump over here to the left, now I've opened my properties dialog box. I can come down here to the transition offset rule pane and take a look at the information I need to demonstrate here. Or I could click on this as I have and go to my properties and look at the same information basically that we see in that transition offset rule. Now what I'm going to do is I'm going to go ahead and stay here with the transition offset rule found on the properties. Let me just open that up a little bit bigger so that we can take a look at that, okay? Now, one of the first things that I want to draw your attention to it's really important. It kind of defines the design intent. We're going to look here under method. Now remember, we're looking here under the transition offset rule. And under the method, you can see the method is offset and ratio. So the design intent is ratio dominant. Now if you click on this down arrow, you can see there's single offset, there's variable offset, and then of course the one that was used here, offset and ratio. And that's important. That's how ORD knows, okay, what we were talking about earlier. That's how Open Roads understands the geometry and what's happening and what design intent is dominant. So in this case, it was offset and ratio. And now what I'm going to do is I'm going to make a little change just for you to see it. I'm going to change this ratio here from 1:4. Let's go to 1:5 and see what happens. And you can see that changed not only the ratio, but the offset value here as it's figuring out what needs to happen on its own. Now, what I want to do is I want to just quickly show you where all these tools are that we're talking about. If we were to go in our Open Roads modeling workflow and we go to our geometry tab, move over here to the horizontal button group, and we'll look here on that split button called offsets and tapers, and you can see we've got a single offset entire element, a single offset partial, variable offset taper, and ratio offset taper. And what we're going to do in the videos that we're going to create moving forward, the lessons that we're going to cover, is we're going to utilize those tools to create some edge of pavements. But that definitely concludes the first portion, the first video. It covers difference between civil geometry features versus plane graphics. rules and relationships with civil geometry features, and how Open Roads understands the geometry. Thanks for watching.